We will now take a close look at a production application involving the use of LLMs, AI agents, Python, GCP, and Docker. That's right, I said production application. This is the real deal. Wake up. If you're new to these technologies, I'll do my best to make them approachable, but you will need some familiarity with Python, cloud computing, and CLIs to follow along easily. If you're familiar with these technologies, I'd love your feedback on the overall design being presented. In this walkthrough, we will build a team of personalized AI agents who will send us daily bullet points highlighting news updates happening across multiple websites. Here's a diagram showing what we'll be building for clarity. This design can be used as the foundation for building many applications, but to get your creative juices flowing, here are two that come to mind. One, you can use this as a productivity hack for staying up to date on a niche that matters to you. And two, you can use this as the foundation for building your own AI-powered newsletter. We'll be building our agents with a Python framework called CrewAI, and we'll be designing our application to run on an easy-to-use platform managed by Google called Cron Job, so our agents run for us 24/7. Here's an overview of the sections that follow so you know what's ahead, and I 100% guarantee this is going to be incredible. You will still get a ton of value if you want to simply watch, but if you want to code along, here's what you'll need. A, you'll need a PC, aka a laptop or desktop. This is going to cost you some money. B, you'll need Docker installed on your PC. Docker is free. C, you'll need a code editor. I suggest VS Code or Cursor. VS Code is free. Cursor has a free trial. FYI, Cursor is an altered version of VS Code, so even though I'll be using VS Code, you should be able to follow along. D, after VS Code or Cursor is installed, install two VS Code extensions, namely the Docker extension and the Dev Containers extension. Both of these extensions are free. E, you'll need a GitHub account. GitHub's free tier will work. F, you need a GCP account. GCP will practically be free. G, you need an OpenAI account. OpenAI will cost you between a few pennies and a few dollars depending on circumstances. H, you'll need a Mailgun account. Mailgun has a free trial. I, you'll need an AgentOps account. AgentOps' free tier will work. And optionally, J, you'll need a domain. I know this sounds like a lot, but it's not that bad. Let me break it down. In regards to Docker, the code editor, and the two VS Code extensions, I'll be playing a clip shortly that shows how I install them onto my M1 MacBook Pro in under a minute. And even though my machine is Mac-based, the broad strokes of what you'll see in that clip will apply to both Linux and Windows machines. In regards to GitHub, you can get an account by coming over to github.com and signing up. In regards to GCP, you can come over to cloud.google.com and sign up. GCP usually offers free credits upon sign up or activation. Plus, the cost of what we're doing in this video will be in the pennies. So the GCP side of things should be practically free, assuming you tear down the GCP project within a couple days of building it. We'll be showing how to tear down GCP projects at the end of the video. So what I'm saying is setting up Docker, a code editor, two VS Code extensions, a GitHub account, and a GCP account is enough to get started. The remaining items can wait till part 5, those being the OpenAI account for powering our agents, the Mailgun account for delivering our AI-generated emails, the AgentOps account for monitoring our agents, and optionally, the domain. If you don't mind the AI-generated emails we create being sent to spam, which I think is okay for learning purposes, don't worry about setting up a domain. But if you do want the AI-generated emails we create to be properly sent to the recipient's inbox, you will need a verified domain. I suggest using whatever domain registrar you're most familiar with. For example, I'll be using Route 53 later in part 6. So let's take a deep breath. Let it all out. If you have any setup or installation issues, leave a comment, or I suggest pasting detailed descriptions of the errors you run into either Google or ChatGPT for assistance. FYI, if you're laser focused, you can complete all of the setup in under 15 minutes. But if you find it to be overwhelming, just do parts A through F and worry about the rest for later. Here's how to download and install Docker Desktop on Mac. Go to the official download page, download the appropriate version. For me, this is Apple Silicon. Open the downloaded DMG file and drag and drop the docker.app icon into your applications folder. I've already done this, so I'll click stop, but that's it. It's that easy. And here's how to download and install VS Code on Mac. Go to the official download page, download the appropriate version. For me, this is Apple Silicon. Unzip the downloaded zip file and drag the Visual Studio Code.app icon into your applications folder. I've already done this, so I'll click stop, but that's it. It's that easy. After installing VS Code, you'll need to do one last thing. Open VS Code and come over to the Extensions Marketplace on the side menu, and you'll need to install two extensions. The Docker extension. You can search for it in the search bar, and once you find it in the panel, you can click on it, and then you'll see these buttons right here. You can click to install it. Should only take one click. It's that simple. B, you'll need the Dev Containers extension. You should see some buttons right here. You can just click to install it. Super simple. And that should be all the setup you need. Welcome. So I'm assuming you have at least these prerequisites installed on your computer. Let's get started by creating a folder somewhere on our computer, perhaps in your home folder. I'm going to create a folder called How to Host Things on Google Cloud Run Jobs. And let's open this folder, VS Code. And if I pop open the terminal built into VS Code and take a look at where we are on the file system, you can see we are in this folder that we just created. Now let's create our dev container. If you're unfamiliar with the term dev container, hold tight. It's going to make sense in a few minutes. In our empty folder, let's create the following folder in files. Let's create a folder called .devcontainer. Inside of this .devcontainer folder, let's create a file called devcontainer.json. And at the root of our project folder, let's create another file called dockerfile.dev. And let's populate the devcontainer.json file with this content. And let's populate the dockerfile.dev with this content. This code looks a bit hectic, but it's actually useful. This code will build a little mini computer called a container that runs on top of our base machine, aka our laptop or desktop or whatever we're using. When we're done with this walkthrough, we can simply kill or delete this container, and our base machine will be left clean from all of the software that we installed into the container. In addition to helping us stay organized, the use of containers is highly compatible with cloud platforms like AWS, GCP, and Azure. So when we get to the point where we're deploying this application to the cloud, it'll make that process super easy. To shed some light on what these files are doing, the dockerfile.dev configures our container, and the devcontainer.json file tells VS Code how to attach to our container when we'd like to edit the files inside of it. Take a closer look at the dockerfile.dev, and we can see we're installing Python. We're installing Git. We're installing gcloud. This is going to allow us to speak to GCP from inside our container. And we're also installing a Docker client. This is going to allow us to speak to the Docker server running on our base machine from inside our container. FYI, when you use a container for the purposes of developing software inside of it, we call it a dev container. Later in this video, when we ship our application to GCP, we're going to make a second container. We're going to refer to that second container as our production container. Because our dev container and our production container are going to be so similar, there's a high likelihood that our code will work exactly as it does in our development environment when we run it in GCP. In a nutshell, using this approach is going to make shipping our code to the cloud very easy. If none of this makes sense, don't worry about it. Let's move on. We can interact with Docker completely from the command line, but Docker also comes with this tool called Docker Desktop. Docker Desktop is a UI for interacting with Docker. And on my local Docker instance, you can see at the moment I have no containers and I have no images. Let's come back to our editor, aka VS Code or Cursor, whatever we're using, and let's type these keystrokes, Shift Command P. This will open up the command palette as it's so called. And in the command palette, you should see an option if you've installed the dev containers extension that says dev containers reopen in container. You can also search for it. Let's select this option and see what happens. When you build a container from your Docker files, the process will usually take a few seconds, maybe a few minutes. It depends on how much software you're packing into the container. So it looks like the build process has completed, and let's come back to Docker Desktop and see what things look like. You can see we now have a few images, and we also have a container. This is our dev container. Let's come back to VS Code or whatever we're using, and let's pop open the built-in terminal and look at where we are on the file system. And you can see now we are in a folder at the root called code. We are no longer in the original folder we created. Moving forward, we will be developing our application inside of this dev container. Let's quickly confirm all the software we'll need is installed in this dev container. We have Python, we have Git, we have gcloud, and we have our Docker client. So everything's looking good. Let's save our progress in a remote repository on GitHub. If I come over to my GitHub account, I will create a new repository called How to Host Things on Google Cloud Run Jobs, and click Create Repository. And there are times for creativity, and this is not one of them. So let's just follow these commands right here. Let's initialize our local repository to be tracked with Git. Let's create a commit. So I'll save all of these changes. And I'm using Git shortcuts that were outlined in the dockerfile.dev. And let's rename our branch to be called main. Let's add our Git remote, as it's so called. This lets our local Git project know where to push code to. And then let's push our code. We can see our project has been backed up. If you have a keen eye, you're thinking, what just happened? So long story short is whatever credentials were authenticated to GitHub with on our base machine get forwarded to the dev container when it's launched. Here we are in the dev container. If I type git push, we can see we're authenticated with GitHub. That's our remote in this scenario. And if I run this same command in this project folder on the host, we can see we're authenticated as well. So on Mac, there's this application called Keychain Access that stores credentials for us when we authenticate with different systems. I think the corresponding application on Windows would be Credential Manager. On Linux, it would be LibSecret. But anyways, so here in the Keychain Access app, we can see a stored credential for GitHub. So if I delete this and try to authenticate with GitHub again, we can see we're prompted for our credentials again. And then let's try it in the dev container. So if I say git push, we're prompted for our credentials again. Here is how I suggest we authenticate with GitHub. So here we are on the page for our newly created repository. If we come to our profile settings, there's an option that says developer settings. You can see this personal access tokens drop down. GitHub has this newish feature called fine-grained tokens. Let's click on that and let's generate a new token. We'll call this token How to Host Things on Google Cloud Run Jobs. And let's restrict this token to only be able to access the repository we just created. This one. And if we open this repository permissions dropdown, let's add contents, read and write permissions. And the only other permission we'll need is metadata permission, but I think this is always enabled by default. And let's generate the token. And we can use this token, let's copy it, to authenticate with GitHub in a very controlled manner. So if I perform this git push command again, it'll prompt for my username. And if I provide that access credential, or that token rather, now we're authenticated again. And if I come to the dev container and try pushing again, we're authenticated in the dev container as well. So long story short is your host machine or base machine credentials or authentication with Git gets shared with a dev container. So we're probably not going to need this personal access token again from GitHub, but let's store it just in case we do need it. So what I'll do is create another file at the root of our project called .env. And let's store this GitHub personal access token as it's called. So I'll say GitHub personal access token, and then I'll paste it in here. And let's also add a .git ignore and make sure that we ignore this .env. Come over to this link. And when you develop Python projects, there's a whole host of files that you do not need to add to GitHub or Git for that matter. So let's add them all at once right now. And I think that does it. So let me save this. So if you have any issues authenticating with GitHub from the dev container as a backup, you can just use a terminal on your host machine. So I will see you in part 2. In part 2, we'll learn how to deploy a simple job to Google Cloud Run. As we're starting from scratch, let's create a new project in our GCP account by coming over to console.cloud.google.com/welcome. It's going to load one of the projects in your account. And if we click this dropdown right here, it'll open up a modal that includes a button saying new project. Let's click on that and create a project called How to Host Things on Google Cloud Run Jobs. Let's click create. And all of the GCP related work that we will be doing will be done inside of this project for organizational purposes. After our project is created in GCP, let's select it and search for Cloud Run in this top search bar and select the option that says Cloud Run. Cloud Run is a managed service for running containers. On the Cloud Run page, you'll see 2 tabs, one that says Services and one that says Jobs. Services in this context are long-running applications like HTTP APIs that need to be listening to the internet for requests. Jobs, on the other hand, are for triggering scripts. These scripts will release the resources needed to run them immediately upon script completion or failure. As this video covers Cloud Run jobs, let's run a simple job to get our feet wet. First, let's authenticate with GCP in our dev container by typing the gcloud init command. And this will take us through an auth flow. And I'll say, yes, I would like to sign in. And if I command click this link and copy it, come over to whichever browser tab or browser instance I'm logged into GCP with and paste it into the URL bar, I'll be able to select my account and I have to give consent and my password, more consent. And then I'm presented with a auth code that I can copy and paste into the terminal that kicked this whole auth flow off. And I'll be asked to select my project, which is 3 for me. And now the dev container is authenticated with GCP. Okay, many gcloud commands are going to ask us to reference our project ID. So let's create a variable for it so we don't have to constantly type it, right? And some gcloud commands require us to specify another identifier for our project, which is called its project number. You can find the project number by coming over to the dashboard of our selected project. And you should see the product number displayed here. Let's copy it. And yeah, trust me, you're going to be very happy that you just did this. So now let's set up our project so that we can run Cloud Run jobs inside of it. So by default, this is the list of GCP APIs that are enabled in a fresh out of the box project. GCP has hundreds of APIs, and now let's enable 2 more of them. And the APIs that we will enable will be the Cloud Run API and the Cloud Build API. And after that completes, let's list the enabled APIs on our project, and we can see that this list has grown by 2 entries. This next command will give the Cloud Run API in our project permissions to talk to a number of other APIs in our GCP account. Okay, that takes care of all of the permissions and APIs we need to enable in order to run a simple Cloud Run job. So the high-level overview of what we're going to do for the remainder of part 2 is, first, we're going to build a little application, a very simple application. Then second, we're going to ship it to Cloud Run jobs. So our little application is going to require 6 more files to be added to our project. These 5. And then we're going to have a helpers folder that will hold 1 file. And let's populate the main.py file with this content, and the requirements.txt file with this content, and the proc file with this content, the dockerfile.prod with this content, the cloudbuild.yaml with this content, and the sayhello.py helper with this content. As we can see, a Python Cloud Run job project is really not that different from other Python projects. So as usual, let's install our dependencies, and that should make this import error go away. If it doesn't go away, try opening up the command palette and restarting the Python language server, but that did fix this import error. And now let's run our script. And it works. So we've built a little application, we've tested it out. Now let's ship it to Cloud Run. The left half of this diagram shows what we have done up till this point, and the right half of it shows what we're about to do. Deployment step number 1 will be to create a repository in Google Artifact Registry. A repository in this context is a place where we can store images. When we build a Docker file, we are left with what is called an image. An image in the context of Docker is a collection of files that defines all of the code and operating system requirements needed to run a particular application. If we recall to when we built the dev container, we remember seeing a few images and a container inside of the Docker desktop UI. When this image, holding all of the configuration of our dev container, was ran, it left us with this container. When we build a Docker file, it leaves us with an image. And when we run an image holding all of the code and operating system requirements of a particular application, it leaves us with a container. We are now going to build our second container, aka our production container, by building the dockerfile.prod into an image holding all of the code and operating system requirements needed to run our application in Google Cloud Run. Because our development container and our production container are going to be so similar, there's an extremely high likelihood that our little application will work exactly as it did in our development container when we run it in Google Cloud Run. If we take a closer look at our dockerfile.prod and our dockerfile.dev, we see the only difference between the two is the removal of a handful of tools. In the dockerfile.prod, we don't need Git, we don't need gcloud, we don't need Docker. These tools are not necessary when running our application in production. So now you understand why Docker is so useful. When you take code that's written on your computer and ship it to other computers without defining all of the operating system requirements it needs, it increases the likelihood that it's not going to work. So what Docker does is package your code with all of its OS requirements so that when it's shipped to other computers, there's a higher likelihood that it will work. Finally, now let's create an image repository in Google Artifact Registry by entering this command. But before we enter this command, let's come over to the GCP console and come over to the Artifact Registry page so we can compare the before and after. And now let's enter this command. And when that completes, let's come back to the Artifact Registry page and reload it. And now you can see we have an image repo. So for clarity, an image repo is not the same thing as a Git repo. An image repo is a place where we can store images, and a Git repo is a place where we can store code changes made to a particular code base. So now that we have this set up, let's build our production image and store it in this repo called repo for job 1. First, we'll do this using cloud build. If we pop open the cloudbuild.yaml file, we'll see a script with 2 steps. Step 1 is building the Docker file.prod, and step 2 is pushing the resulting image to the repository we just created in Artifact Registry. And the URLs of repositories in Google Artifact Registry have to follow this specific format. If they don't follow this format, things will not work. And the last thing I'll mention is we can see that there is a colon at the end of the repository URL followed by a string. This is the tag of a particular image. This is a way that we can give a custom ID to each image that we store in a particular repository. The default tag is latest. This hints to us that this version of the image is the latest one. And we're not going to be using this tag feature pretty much at all, but it's useful to know about, and it's useful for QA. And sometimes you'll use the Git hash to identify each version of a particular image. This is useful for storing a history of all the versions of an application, etc. So anyways, let me stop rambling and let's build our production image and store it in the repository we just created by sending it to cloud build with this command. While that's building, I'll come back to the GCP console, and you can see that inside of our repository, we currently have no images. And when this script is finished, we should see an image inside of our repository. Okay, the script finished in cloud build. Let me reload this page, and now you can see we have an image inside of our repository. And second, we'll do this with a Docker client inside of the dev container. All right, this is what this looks like. We have to build the Docker file.prod and tag it with the appropriate image URL format or repository URL format. And notice how we're also including this platform flag that reads Linux AMD 64. I'm guessing the hardware that powers Cloud Run is provided by AMD. And we have to retrieve an access token from GCP. And then we log into Artifact Registry like so. So we provide this access token as the password. And that worked. And then we have to enter this command. And when we push our image, it should work. And it does. Now that we have our production image stored in a repository in Google Artifact Registry, let's run our first job ever. We finally made it back to Cloud Run. So let's come over to the Cloud Run page and come over to the Jobs tab. And what we're going to do is register a job with Cloud Run that uses the image that we stored in our repository as the application that will get triggered when we trigger the job. So here's what that looks like. This is the command that will register a job in Cloud Run Jobs. Here we specify the job's name. First Cloud Run job ever. And here is where we reference the image in Artifact Registry that we would like to use as the application that gets triggered when we trigger the job. So if I enter this command and come back to the Cloud Run page, and that command finishes executing, we can see we now have a job registered in Cloud Run Jobs. And here is how we trigger the job. So we execute this command and provide the job's name. And if we come over to the Cloud Run dashboard again and select the job, we can see the job's logs here. And we should see the same exact output that we were seeing when we were running this application in our dev container. And there we go. We see the same logs that we were seeing in the dev container. So that's great. We now know how to manually deploy containerized scripts to Cloud Run jobs. Next up, we'll automate this deployment process using GitHub Actions. We are now going to automate the deployment of our simple job using GitHub Actions. The way that we do this is by creating a folder at the root of our project called .github. And inside of this .github folder, we're going to create another folder called workflows. And inside of this workflows folder, we're going to create a file called CICD.yaml. Here is the content that we will paste into this CICD.yaml file. And by placing this YAML file at this specific location of our project, whenever we push to the main branch of our GitHub repository, this code inside of it will automatically get triggered. If we look closely at this CICD.yaml script, we can see it's requiring us to specify some GitHub variables, as well as a GitHub secret. The way that we provide these values is by coming over to our GitHub repository, and you should see a tab that says Settings. In the Settings tab, there is an option that says Secrets and Variables, and it has a sub option that says Actions. On these two tabs is where we can provide our secrets and our variables. First, I'll provide all of the variables. One of the variables of our CI/CD script is going to be our project ID. And the next one will be our project number. And the next one will be the name of our job in Cloud Run. And second, let me show you how to generate the secret that we'll need. So if we come over to console.cloud.google.com and make sure our project is selected, if we come over to the IAM and admin option and select the service accounts sub option, here is where we can create a service account, which is a fancy way of saying a username and password that we give to an application so that it has the permission to do what we want it to do. So let's create a service account, and I'm going to call this service account How to Host Things on Google Cloud Run Jobs CICD Service Account SA. And we'll add a description so that we know what this is for. If we come back to this a while from now, done. To the key now, you might have noticed that there was already a service account sitting in this list before we ever created a service account. So by default, GCP creates this default compute service account, as it's so called, and gives this service account to a number of APIs so that they have permissions to do what they need to do. So now if we select the service account from this list that we just created and come over to the Keys tab, we'll see this drop-down button that says Add Key. Let's create a new key. We'll use the JSON key type, click Create, and a file will be downloaded to our computer, and the contents of this file will be our secret. So let's copy the contents of this downloaded JSON file and come back to our GitHub repository and create a new secret. I'll call it GCP CICD SA key. Then we'll paste in our service account key, add our secret, and then that takes care of setting up all of the secrets and variables for our CICD.yaml script. Now we're ready to test out our CI/CD automation with GitHub Actions. Let's come over to the Actions tab on GitHub, and we have nothing here at the moment. And let's come back to our project, and let's push our latest changes to GitHub and see what happens. Okay, so we need more permissions added to our personal access token. So let's come back to GitHub and come over to the settings section, and let's come over to the developer settings option, find the personal access tokens drop down, come over to fine grained tokens, and here's our personal access token. And we need to add more permissions. Okay, so we need workflow permissions. And let's try to push again. All right, that worked. Come over to the actions page and reload. So as we can see, it failed. And if we click on the automation, we can see that we're failing because we're not able to upload images to Artifact Registry. This is the command that will grant our service account those permissions. So now we can re-trigger our CICD automation. And it failed, and it's more permission stuff. This is the command that will grant the next slew of permissions we need to give to our service account. And it looks like it worked. And it's more permission stuff. So this is the command that will give our service account the next slew of permissions it needs. And that looked like it worked. Our automation completed successfully, so we're definitely moving in the right direction. Now what we're going to do is check out the logs of the Cloud Run job, and we're going to make an update to our application and confirm in the logs that our update gets propagated to the Cloud Run job hosted on Google. So let's test this out. Here is the command that will trigger our job. We can see that it got triggered again, right? And we get more logs. So now what we're going to do is let's make an update to our application. Instead of saying hello, let's, say, hello, daddies. And let's save this change. Push it. And in GitHub, on the Actions tab of our repository, we see that another run of our automation is in flight. And after this has completed, we're going to trigger our job again, and we should see this line in the application logs say, hello, daddies. All right, so it completed. And now let's trigger our job again. And we see our job got triggered for a third time, and it just completed. So we should have some more logs, and indeed, this log line got updated. So everything is working. In part 4, we're going to learn how to automatically trigger our job on a regular schedule using another GCP product called Cloud Scheduler. In order to use Cloud Scheduler, we need to enable the Cloud Scheduler API. So let's do so by entering this command. And when that completes, if we list out all of the enabled APIs in our project, we should see an additional entry. Here we are, Cloud Scheduler API is now enabled. Now we can create a cron job. A cron job, for those who have never heard the term, is a scheduled task that runs on a regular interval. The way that we define the interval for a cron job is with this expression format. For example, this would be the expression for once a minute. This will be the expression for every Monday at 9 a.m. This will be the expression for the 1st and 15th of each month at 2 p.m. And this will be the expression for every 5 minutes between 8 a.m. and 10 a.m. Here is the gcloud command template for creating cron jobs in GCP with Cloud Scheduler. The only variable whose value we don't yet have is the service account. So let's create a new service account with the minimum needed permissions to trigger jobs in Cloud Run. And this time, let's create the service account using the command line. All right, here's how we create service accounts from the command line. And now we need to add invoker permissions for Cloud Run to this service account. And this is how we do so. And if we list out all of the service accounts in our project, we see we have 3 now. So in the gcloud command template for creating cron jobs with Cloud Scheduler, let's replace the variables with the following values. Before we enter this command though, let's come back to the console and come over to the Cloud Scheduler page. And we currently see no Cloud Scheduler jobs displayed. So if we enter this command now, when it completes, we should see a cron job registered in the console, and we do. And if everything's working as expected, if we come to Cloud Run and take a look at the page for our job, we should see it getting triggered once a minute. Yep, you see that? So yeah, as we can see, everything's working. We see our cron job listed as a trigger here on Cloud Run, and our application logs are also getting printed out each time the job gets triggered. So this is fabulous. We now know how to set up cron jobs on Google Cloud Run jobs. Now we're going to add in some AI. Let's update the requirements.txt to contain the following third-party packages. And let's update the main.py file to contain the following contents. And you can see a number of import errors at the top. So let's sort those out by creating the following files. Let's create another helper file. Let's add a folder for storing the schema for this application we'll be building. And let's add a config folder with a tasks.yaml file and an agents.yaml file. And let's populate the helper and the schema folder and the agents.yaml file and the tasks.yaml file. And of course, let's pip install. If we look closely at this config folder, we can see we're creating a team of agents who are reporting the latest news regarding Haiti. This is what we're going to roll with for demonstration purposes, and you can easily tweak these prompts according to the niche you're interested in. Let's now run this updated application and see what happens. All right, we get an error that says missing OpenAI API key. By default, CrewAI, the multi-agent framework we're using, uses OpenAI for powering LLMs. It supports other LLMs, but as I mentioned, OpenAI is the one that it supports by default. If you're new to all this agent stuff, here's a diagram that shows what I mean. And in the context of this video, an agent is a virtual person, and the LLM acts as this virtual person's brain. We can get an OpenAI API key by coming over to platform.openai.com and signing up. After you're signed up, make sure to add some credits to your account. OpenAI's platform is pay per use. It's like a gas station. And I suggest adding whatever the minimum allowed amount is, because the cost of what we'll be doing here is only going to be in the pennies. After you have credits added to your account, come over to the dashboard API keys section and create a new API key. Call it whatever you want. You can leave every option default, by the way. And then copy the provisioned API key into your project by coming over to the .env file and adding a new entry that reads OpenAI API key equals, then paste in the API key. And when that's all set up, let's try running our application again and see what happens. It looks like it's working. If we take a closer look at this config code, we can see we're creating two agents, a manager agent and a reporter agent. And this is the task that we're assigning to these agents. We would like them to perform research across this list of websites. And if we come to the main.py file on line 56, the configuration gets tied together. As of the time of recording, CrewAI lets you run your agents in two modes, sequential mode and hierarchical mode. Sequential mode means that the agents are going to perform the tasks outlined in the tasks.yaml file sequentially from top to bottom, one by one. With sequential mode, you have to map each task to the agent you want to perform it. In hierarchical mode, which is what we're using, we assign one of the agents in our crew as the manager, and we assign tasks to the manager. The manager will automatically break up the task we assign it into subtasks and will automatically assign each subtask to the appropriate agents in the crew. If you're familiar with this agent stuff, one way of thinking about it is the worker agents become tools of the manager agent. Depending on the LLM and other implementation details, the reliability and reproducibility of running hierarchical mode agents can sometimes be impressive and can sometimes be atrocious. But for the job of synthesizing information across a number of websites, I find hierarchical mode to be a worthy match. Let's run this crew of agents a few times to get a better feel for what it's doing. Let's come over to the tasks.yaml file and let's edit this list of links to only have one. And then let's run our crew. If we come back to the main.py file, we can see that the crew will be spitting out its results into a file called report.md, this file right here. So let's wait till the crew is finished running and let's see what it spits out into this report.md file. All right, it finished running and let's open this up. And we can see that we're getting news from the one website that we have listed in the prompt. All of these are coming from the same source. Now, let's add the second website in this list. So if this is working as expected, we should see news results from two websites. All right, it finished running and you can see now we're getting news results from two different websites, right? You can see in the sources, the source link is coming from the two websites we have listed in the prompt. All right, just to make sure this is working as expected, let's add a third website to this list and have our agents perform research on these three news outlets. And when I say research, what's happening is the agents are instructed to load all of the text on each web page, and they're prompted to extract the most meaningful or the most relevant information given the current date. So here we are. If this works, we should see news results from three separate sources. All right, so our crew finished running. And yeah, so this first result is coming from Haiti.loopnews.com. This second result is coming from thenouveliste.com. And this third result is coming from HaitianTimes.com. So things appear to be working, and I hope that gives you a good feel for what this little multi-agent application is doing. Okay, so using this report.md file is useful for debugging, but we don't need to track it in Git. So let's add another entry to the Git ignore. And now we're ready to move on to part 6. In part 6, we're going to send this AI-generated news report via email to a list of subscribers. Next up, we will integrate email into our application. There are many email providers we could use, but for demonstration purposes, we will go with Mailgun. I'm suggesting Mailgun as I found their integration process to be straightforward, but feel free to use another email provider if you prefer. Anyways, come over to signup.mailgun.com/new/signup. After you sign up, you have to verify your account via an authorization code that you'll receive either in your email inbox or on your phone. After you complete the account verification process, you can provision an API key. This API key is what will authenticate our application with Mailgun's email API. Next, let's come over to the domains page. And we can see that Mailgun gives us a free domain for testing. We can send emails from this test domain to any email address we list as an authorized recipient here. To authorize a recipient, we enter the email here and save it. And then the owner of the email will receive a consent email that they'll have to agree to if they want to receive emails from our test Mailgun account. After we authorize some email, let's add some code to our application to test out our Mailgun integration. So let's create a file in the helpers folder called send email. And here is the code that we will populate this file with. And let's call this code from the main.py file here. And we have to import this helper. And for testing purposes, let's comment out all of the code except the send email call and run our application to see what happens. Okay, if we come to our inbox and refresh our inbox, we see nothing. But if we come over to our spam folder, look at that. We just received an email. 12:08 a.m., 12:08 a.m. In regards to this video, if you don't mind emails being sent to spam, skip ahead to part 7. But if you'd like the emails we send to arrive in the inbox as expected, here are the steps you'll need to take. Come over to the Mailgun domains page and add a particular subdomain of a domain you own. For example, I used mail.wishbliss.link. Wishbliss.link is the domain, mail.wishbliss.link is the subdomain. After you add a domain, you'll be presented with some DNS records that you need to add to your DNS settings. Here are what these Mailgun records look like in my Route 53 account for reference. After you have your DNS settings updated, you can click this verify button to have Mailgun verify that we are indeed the owner of this domain. And now when we send emails from our verified domain, they should arrive in our inbox as expected. Voila. If you have issues purchasing a domain or setting up DNS, leave a comment, or I suggest pasting detailed descriptions of the issues you run into either Google or ChatGPT. Setting up a custom email domain is not too difficult, but if you've never done it before, it can be a bit tricky. If anyone in the community knows of an easier way to set up emails for the purposes of this walkthrough, please leave a comment and I'll pin it to the top of the comments. Let's move on to part 7. We are now going to make most of the remaining changes that will move us towards the final form of our application. So pay attention closely. First of all, we do not want this AI-generated research report to be written to a file, but instead would like it delivered to us via email. So to do that, let's make this little change to this task object. Let's test this out so you see what it's doing. We can see that our crew has now generated a JSON structured output of the news report. So what we can now do is combine the flexibility of LLMs with the predictability of traditional programming to transform this JSON structured output into the body of an email. To do that, let's add a few more helper functions. And let's add this code to the format news for email helper function. And let's add this code to the isValidEmail helper function. And let's update the main.py file on lines 71 to 74. And then let's import these helpers. Finally, let's update the send email helper. And now if we test our application, let's see what happens. If it works as expected, we should receive an email with our AI generated news report. All right, our application just finished running. And if we come over to our inbox, we see our AI generated news report. And the links are working too. Great. We are now going to use another product in the GCP suite called Secret Manager. Secret Manager is a product specially designed for storing API keys, secrets, and any other sensitive data. Here's how we enable this API in our GCP project. And after that command completes, if we list the enabled services in our GCP account, we can see that this list has been extended by one entry. So this is how we would add the OpenAI API key to Secret Manager. You can see we're piping in the API key into this gcloud secrets create command. And this is the name of the secret in Secret Manager. And this is how we would pipe in the Mailgun API key so that it's stored in Secret Manager as well. FYI, here's how you update secret values. Anyways, the last thing that we need to do before we test this is make sure that our default compute service account has the permissions to access these secrets in Secret Manager. So let's first run this command and then this command. Once again, for clarity, what these commands are doing are giving Cloud Run the ability to retrieve these secrets from Secret Manager when we run our application. All right, now we're ready to test this. So let's come over to the CICD.yaml file and come to the deploy step. And let's add another flag called set secrets. And you can see that this flag is passing in the environment variables for our API keys by referencing them in Secret Manager. So it's doing that for the OpenAI API key as well as the Mailgun API key. So let's quickly come over to the git ignore. Same way that we ignored the report.markdown file, let's also ignore the report.json file. This is only useful to us for debugging purposes. So that looks good. So we go, say, nearly finished. Okay, I'm actually glad this happened. So the build failed because we need to add some additional software into the container. So we're using a multi-agent framework called CrewAI. CrewAI has what are called tools, which are add-ons that you give to your agents that allow them to do things. For example, there's tools for browsing the internet. There's tools for accessing the files on your computer. There's tools for generating images. These all come to you with CrewAI. So some of the tools require some C++ libraries to be installed, and we need to add these C++ libraries into our production container. So we will put this here. Build Essential is going to add some extra C++ libraries into the container. So let's test this out. And woo, it worked. Let's trigger our job in Cloud Run to confirm we still get AI generated news delivered to us via email. Okay, our job got triggered. And now it's running. And it was able to complete. So if we come to our inbox, we do indeed get our AI generated news report. So that's great. This application works in our dev container and it works in Cloud Run. So we're looking really good. Before we wrap up part 7, let's discuss a few of the flags available to us when running jobs in Cloud Run. So we can see in the YAML config for our job that we have the ability to specify the amount of memory allocated to each container when it runs a job, the amount of retries the container is allowed to make before the job is reported as failed to us, the timeout seconds. So this looks like 10 minutes timeout. So what we're going to do is tweak the memory and tweak the max retries. Because agents are probabilistic by design, they're always going to work differently every time. I've seen them sometimes generate so much text to where they consume all the memory allocated to them when they're ran in Cloud Run jobs. So what we're going to do is double the amount of memory that is given to a Cloud Run job container by default. And we're also going to increase the max retries from 3 to 5. And here's how we'll tweak them. We will come over to the deploy command in our CICD script and add 2 more flags. All right, that worked. So let's quickly confirm that our configuration got updated. And yeah, you can see we now are at 5 max retries and we have double the memory that we had before. So moving on. Next, we are going to add in an amazing tool called AgentOps. AgentOps will allow us to monitor our agents in a much more intuitive and simpler fashion than digging through GCP. You're going to need a tool like AgentOps when you have dozens or even hundreds of agents working for you, so you get an overview of what they're all doing, how much each of them is costing you, etc. So I'll see you in part 8. The process for integrating with AgentOps is very similar to how we integrated with OpenAI. First, let's come over to the AgentOps web app, come over to app.agentops.ai, and find the API keys page. I found it in this drop down. And let's create a new one. Let's create a project called Agents Masterclass. And then let's copy the API key that was created for us. And we add it to our project by adding a new entry in the .env file that reads AgentOps _API _key. And we paste in the API key that we copied from the AgentOps dashboard. And then let's come over to the requirements.txt file. And we need to add the package for installing AgentOps. And let's save this file and then pip install as usual. And the final step of integrating AgentOps involves coming over to the main.py file and towards the top of this file, before you initialize your agents, add this bit of code. And we also need to import the OS package. So if we run our application, we should see some information showing up in the AgentOps dashboard. And AgentOps offers this overview dashboard as well as this drill down. And there we go. So we're starting to see some data come in. All right, we see our product manager agent, our researcher agent, and our agents are still at work. So let's see what the AgentOps dashboard looks like when our agents are finished. And if we reload, right, we see some beautiful charts giving us an overview of what happened when our agents were at work. On the right here, we can see the details of what the LLMs produced and ingested for each step of the overall session. And we also see the costs involved, as well as all the versions of the libraries that were used under the hood. And this is fantastic. And this page gives us an overview of what just happened as well. To set up our agents in GCP, aka our production environment, we must add the AgentOps API key into Secret Manager, and then give our default compute service account permissions to access this AgentOps API key. And then we reference the AgentOps API key in Secret Manager in our CICD.YAML script. Let's push these changes to GitHub. Okay, that worked. And now let's trigger our agents in Cloud Run and confirm that they still work and that they are being tracked by AgentOps. So here is the command. All right, so our job got triggered. And it's running. And let's come back to AgentOps. And here we are. We see our GCP agent session being tracked by AgentOps as well. Taking a look at what our agents are doing via this dashboard is a lot more intuitive and straightforward than digging through the GCP console. We have now arrived at the end of this incredible journey. We are masters of agents and we are masters of our fate. To wrap things up, let's do a few final things. Let's update our prompts to focus on a different niche. So, insurance technology. And instead of focusing our task on Haiti, insurance technology. And instead of focusing on these news sources, let's focus on these ones. And let's also make the subscriber list a secret so we don't dox whoever is receiving news reports from this application. So let's define the subscriber list via an environment variable for now. You'll probably want to do this with some sort of database, but that's outside of the scope of this video. And let's Turn that into an array like so. And let's create an environment variable in secret manager. I'm just going to put one email for now, but you would put a comma separated list of emails. And then of course we have to give the default compute service account permissions to access this secret. And then we reference this secret in our CICD.yaml script. This is the final batch of changes. We now have our production grade application. As promised, here's how to tear down the GCP project and avoid incurring charges. So my suggested approach is to delete all of the resources that were provisioned. So here I'm deleting the cron job. Next, I'm going to delete the Cloud Run job. Then we'll delete the repository in artifact registry. Then we'll delete the service accounts. Then we'll delete the secrets in secret manager. And then we come to the GCP console, dashboard, project settings, and shut down our project. The reason why we have to manually delete all of these resources is because with this shutdown policy, there'll be a 30-day grace period or billing period that's still in effect until all of the resources get shut down. I guess a good side of that is that if you accidentally shut down a project, you have 30 days to change your mind and, disable the shutdown. But from a billing standpoint, if you have anything that's costing you money, you'll be billed for, another month after you select the project for shutdown. So I think that's everything. Namaste.